Operations with polynomials. The addition and subtraction of algebraic expressions can be carried out in two ways by writing them in 1. Horizontal form, 2. Column form. For example, 3x minus 5 plus 6x square plus x cube minus x raised to the power 4 and 6 minus 5x plus 2x cube plus 3x cube plus 3x raised to the power 4. Solution. Horizontal method. 3x minus 5 plus 6x square plus x cube minus x raised to the power 4 plus in the brackets 6 minus 5x plus 2x cube plus 3x square plus 3x raised to the power 4 is equal to in the brackets 3x minus 5x plus in the brackets 6x square plus 3x square plus in the brackets x cube plus 2x cube plus in the brackets minus x raised to the power 4 plus 3x raised to the power 4 plus in the brackets minus 5 plus 6 grouping like terms is equal to minus 2x plus 9x square plus 3x cube plus 2x raised to the power 4 plus 1 combining like terms which is equal to 1 minus 2x plus 9x square plus 3x cube plus 2x raised to the power 4. Arranging in ascending order of degrees. Column method. 1. We arrange the like terms in separate columns in the standard form. 2. We add each column taking the signs of the terms into consideration. 3. We add up the coefficients of the terms in each column and write the sum as a term of the answer. Add, writing the terms in columns. Minus x raised to the power 4 plus x cube plus 6x square plus 3x minus 5 plus 3x raised to the power 4 plus 2x cube plus 3x square minus 5x plus 6 is 2x raised to the power 4 plus 3x cube plus 9x square minus 2x plus 1. Answer. While subtracting in columns, 1. We write the minuend above. 2. We write the subtrahend below the like terms of the minuend. 3. We change the sign of each term of the subtrahend. 4. Add up the like terms column-wise to get the remainder using changed signs of the subtrahend and not the original ones. Example. Subtract 4p square q minus 3pq plus 5pq square minus 8p plus 7q minus 10 from 18 minus 3p minus 11q plus 5pq minus 2pq square plus 5p square q. Solution. Horizontal method. In the brackets 18 minus 3p minus 11q plus 5pq minus 2pq square plus 5p square q minus in the brackets 4p square q minus 3pq plus 5pq square minus 8p plus 7q minus 10. As we know, if bracket is preceded by a negative sign, then while removing bracket, we change the sign of each term is equal to 18 minus 3p minus 11q plus 5pq minus 2pq square plus 5p square q minus 4p square q plus 3pq minus 5pq square plus 8p minus 7q plus 10 is equal to in the brackets 18 plus 10 plus in the brackets 8p minus 3p minus in the brackets 11q plus 7q plus in the brackets 5pq plus 3pq minus in the brackets 2pq square plus 5pq square plus in the brackets 5p square q minus 4p square q, which is equal to 28 plus 5p minus 18q plus 8pq minus 7pq square plus p square q. Multiplication of two monomials. Method. To multiply two monomials, we follow the following steps. 1. Multiply the numerical coefficients of the monomials along with their signs and write the product. 2. Multiply the like variables. That is, add the exponents of the like variables and write their product. 3. Multiply the two partial products obtained in step 1 and step 2 to obtain the final product. Example 1. multiply A minus 6a square b square by minus 7ab, b pqr by minus 3p cube q square r. Solution: A minus 6a square b square into minus 7ab is equal to whole bracket in the brackets minus 6 multiplied by in the brackets minus 7 in the brackets a square into a in the brackets b square into b, which is equal to 42 multiplied by a raised to the power 2 plus 1, b raised to the power 2 plus 1, which is equal to 42a cube b cube. B pqr into in the brackets minus 3p cube q square r, which is equal to 1 into in the brackets minus 3 in the brackets p into p cube in the brackets q into q square in the brackets r into r, which is equal to minus 3
p raised to the power 1 plus 3 q raised to the power 1 plus 2 and r raised to the power 1 plus 1,
which is equal to minus 3 p raised to the power 4 q cube r square. Example 2. Obtain the volume of a rectangular box with the following length, breadth and height respectively: xy, 2x square y, 2xy square. Solution: volume of a rectangular box is equal to length into breadth into height, or volume is equal to xy into 2x square y into 2xy square, which is equal to 2 into 2 in the brackets x into x square into x into in the brackets y into y square, which is equal to
4x raised to the power 1 plus 2 plus 1, y raised to the power 1 plus 2,
which is equal to 4x raised to the power 4, y raised to the power 4. Multiplication of a monomial with a binomial. For multiplying a monomial with a binomial, we use distributive property of multiplication over addition and subtraction. We have learnt this property in our previous classes. Let us revise the rules. X into in the brackets y plus z is equal to xy plus xz. X multiplied by in the brackets y minus z is equal to xy minus xz. Example 1. Find the products. A. 3xy into in the brackets 4x square plus y. B. 6p square into in the brackets pq plus q square. Solution: A. 3xy into in the brackets 4x square plus y is equal to in the brackets 3xy into 4x square plus in the brackets 3xy into y, using distributive law, which is equal to in the brackets 3 into 4 into in the brackets x into x square into y plus 3x into in the brackets y into y, which is equal to 12x raised to the power 1 plus 2y plus 3xy raised to the power 1 plus 1, which is equal to 12x raised to the power 3y plus 3xy raised to the power 2. B. 6p square into in the brackets pq plus q square is equal to in the brackets 6p square into pq plus in the brackets 6p square into q square, which is equal to 6p raised to the power in the brackets 2 plus 1 q plus 6p square q square, which is equal to 6p raised to the power 3 q plus 6p square q square. Example 2. Simplify a cube into in the brackets 2 minus a square into in the brackets a minus 3 plus 6a into in the brackets a plus 4. Solution: a cube into in the brackets 2 minus a square into in the brackets a minus 3 plus 6a into in the brackets a plus 4 is equal to a cube into 2 minus a cube into a minus a square into a plus a square into 3 plus 6a into a plus 6a into 4, which is equal to 2a cube minus a raised to the power 4 minus a cube plus 3a square plus 6a square plus 24a, which is equal to minus a raised to the power 4 plus in the brackets 2a cube minus a cube plus in the brackets 3a square plus 6a square plus 24a, collecting like terms, which is equal to minus a raised to the power 4 plus a raised to the power 3 plus 9a raised to the power 2 plus 24a, combining like terms. Multiplication of a binomial with a binomial. Example: multiply the binomials. In the brackets 2pq plus 3q square and in the brackets 3pq minus 2q square. Solution: in the brackets 2pq plus 3q square multiplied by in the brackets 3pq minus 2q square is equal to 2pq into 3pq plus 3q square into 3pq plus 2pq into in the brackets minus 2q square plus 3q square into in the brackets minus 2q square, which is equal to 6p square q square plus 9pq cube minus 4pq cube minus 6q raised to the power 4, which is equal to 6p square q square plus 5pq cube minus 6q raised to the power 4. Multiplication of a trinomial with a monomial or a binomial. For multiplying a trinomial with a monomial or a binomial, we use distributive property again. Example 1. Multiply in the brackets x cube plus 3x square minus 5x by 4x square. Solution: 4x square into in the brackets x cube plus 3x square minus 5x, which is equal to in the brackets x cube into 4x square plus in the brackets 3x square into 4x square minus in the brackets 5x into 4x square, which is equal to 4x raised to the power 3 plus 2 plus in the brackets 3 into 4 in the brackets x raised to the power 2 plus 2 minus 5 into 4 in the brackets x raised to the power 1 plus 2, which is equal to 4x raised to the power 5 plus 12x raised to the power 4 minus 20x raised to the power 3. Example 2. Simplify in the brackets x plus y into in the brackets x square minus xy plus y square. Solution: in the bracket x plus y into in the brackets x square minus xy plus y square, which is equal to x into x square minus x into xy plus x into y square plus y into x square minus y into xy plus y into y square, which is equal to x cube minus x square y plus xy square plus yx square minus xy square plus y cube, which is equal to x cube plus y cube.
Division of polynomial by a monomial. Knowledge of division of integers and quotient law of exponents will be used here. So, let us revise that. A. Positive integer divided by positive integer is equal to positive integer. B. Positive integer divided by negative integer is equal to negative integer. C. Negative integer divided by positive integer is equal to negative integer. D. Negative integer divided by negative integer is equal to positive integer. Quotient law of exponents states that x raised to the power m divided by x raised to the power n is equal to x raised to the power m minus n. For example, a raised to the power 4 divided by a raised to the power 2 is equal to a raised to the power 4 minus 2 is equal to a raised to the power 2. Method: to divide a polynomial by another monomial, we follow the following steps. Step 1. Divide the coefficients and get the quotient. Step 2. Divide the like variables and get the quotient. To divide like variables, powers of variables are subtracted. Step 3. Get the product of the quotients obtained in step 1 and step 2.
Example. Divide A. 18a raised to the power 2 b raised to the power 3 by minus 2ab. B. 12a raised to the power 8 b raised to the power 8 divided by minus 6a raised to the power 6 b raised to the power 4. Solution. A. 18a raised to the power 2 b raised to the power 3 divided by minus 2ab
is equal to 18a raised to the power 2 b raised to the power 3 by minus 2ab is equal to minus 18 by 2 a raised to the power 2 minus 1 b raised to the power 3 minus 1 is equal to minus 9 a raised to the power 1 b raised to the power 2 is equal to minus 9ab raised to the power 2.
B. 12 a raised to the power 8 b raised to the power 8 divided by minus 6a raised to the power 6 b raised to the power 4
is equal to 12a raised to the power 8 b raised to the power 8 by minus 6a raised to the power 6 b raised to the power 4 is equal to minus 12 by 6 a raised to the power 8 minus 6 b raised to the power 8 minus 4 is equal to minus 2a raised to the power 2 b raised to the power 4.